So let's take a look around Microsoft Excel. The first step is to open Microsoft Excel. If you can't do this step, that's not good. But I'm sure everything will be okay. I have Excel here in my toolbar. You might have to navigate in the program menu. If you're on campus, there it is. So this is Excel. You'll get a splash screen, and we're just going to open a blank workbook. And that gives us our main work area here. And so this is it. Excel is a spreadsheet program, meaning that you have data organized into what you see here. This is a workbook, and this is one sheet. You can see it's organized into a grid, a two-dimensional grid in this case, where you have columns. Columns are labeled with letters, and rows. Rows are labeled with numbers. And this is worksheet 1, as you can see in this tab here. I could rename worksheet 1 by double-clicking this and call it my main demo worksheet. And I could add multiple worksheets by clicking the plus. And you can toggle between these worksheets. Doesn't look like I'm toggling between worksheets because there's nothing in them right now, but there will be soon. So the columns labeled as letters, and you can have over 16,000 columns. As soon as you get to D, you go to AA, just like my uncle. And you're going to keep going. It'll get to BB, so on and so forth. As far as rows go, you can have over 1 million. There are over 1 million possible rows in an Excel worksheet. And so that gives you a lot of room for data. And the main unit of the worksheet are these cells. You can see that I can select a cell by clicking on it, and every cell, the most important thing you need to know is that it has an address. The address is very simple. It is just the column followed by the row. So this is F6. This is D6. And that leads me to the name box right here. As I make a selection, you can see that the label of the cell in question comes up in this name box. Now if I hold down my mouse, I can select a range of cells. So there's a range of cells going from D5 in the upper left hand corner to O25 in the bottom right hand corner. If you make a selection and then hold down the control key, you can make non-adjacent cells all part of your selection. And here's another way to make a selection. You can directly select from the name bar. So if I want to select a range of cells, well, let's just start with E2. If I type in E2 into the name bar and press return, I select E2. Let's say I want to select a group of cells from E2 in the upper left-hand corner to, let's say, J15. What you do is you put the colon in the middle, and that just means the adjacent cells between E2 in the upper left to J15 in the bottom right. Push return, and Excel makes the selection. One final thing on selecting cells this way, you can select non-adjacent cells with the comma delimiter as opposed to the colon. So let's say I want C2 and cell E14. I'm putting a comma there, and I get both cells in my selection. If I wanted E2 to F4, in addition to the non-adjacent rectangle of, let's say, J4 to K17, notice I've got a comma separating my contiguous rectangles. And there we go. You almost never use that, but you know, this is school, so you learn a lot of things you're never going to use. Let's take a look around. Now, you don't have to know all of this stuff right away. We're going to go through much of it in this course, but I just want to orient you to the basic tools you have in Excel. So first of all, the most important part of what we're going to use is right here. This is the formula bar. So the formula bar you can click into, and so what goes in here is the contents of the cell, which I haven't actually done yet. So let's enter contents into cell A1. You could do that by either clicking A1 You don't need to click into the formula bar, but you can. So you could put text in there, you could put a number in there, or you could put a formula. And no matter what, all the contents are always going to appear here in the formula bar. A formula always starts with equals, so I could say 1 plus 1. And again, the way Excel knows that you actually want it to perform a computation is that you put the equal sign. If I push enter, that equation, that formula will be evaluated to 2. So you can expand the formula bar in engineering. Sometimes we need to do that because our equations are horrifically long sometimes. We can keep it down here for now. And other things you can do, if we go to the bottom right hand corner, you can see you have a zoom bar. So you can zoom in, which is sometimes helpful. You can also click on the percentage there and get to some presets. 100% usually works pretty well. And that leads us to the ribbons. So the ribbon tabs, like all of the new Office products, are going to contain easy access to grouped commands and tools. So let's just run through the highlights, and then we'll call that an introduction to Excel. So on the File tab, this works a lot like the other Office products, where you have your basic saving options and exporting options and protecting options. So don't need to go into that too much. If you're used to working with Microsoft, then this is the new regime. The Home tab contains pretty much modifiers and formatting tools. So you've got your fonts, your alignments, your number formatting, some of the styles you can use to fill in your cells in your workbooks, and also some find and select tools. The insert ribbon, and I'm just clicking on insert, and you can see that the ribbon changes. These are all kinds of objects you could potentially add into your spreadsheet. So things like shapes and drawing tools that can come in really handy. Some stuff over here I don't care about. Charts, which will be really big for us in COM 220, and other things like equations, symbols. Also, I might point out the text box, really useful. Sometimes you just need to have a box of text somewhere. If you click that, then you can see it allows you to add a text box, period. And of course, you could select that and modify it in the Home ribbon. Okay, I'm going to delete that because I don't need it. Page layout is going to have to do with the layout of your page as it exists as a virtual piece of paper. So things like your margins, your orientation, your size. One handy thing I might point out here, just like in Microsoft Word, but this is maybe even a little more important for Excel because spreadsheets have various dimensions. You can force the width of your worksheet to one page. So a lot of times you have a lot of columns and you want to print out on one page, and you can also do this with the height. So that's really helpful, I've found. Also grid lines and headings. So you can see the grid lines that define the cells, but those don't actually print out. So an easy way to do that is you select print, and then these lines that define the cells themselves will occur in the printout. But they don't actually do that unless you click this. And you could undo the view, so you wouldn't even be able to see them in the view mode. But that's handy. The Formulas tab has everything to do with the calculations and functions that you can use to manipulate and compute data. And it's not just data, text. A lot of times spreadsheets are used purely for text without any mathematical computations at all. And you can see some of the categories, and we'll be going through a lot of these. Data, the data ribbon has to do with sorting and viewing the data. You can, if you have a big spreadsheet, you can sort it by any column. You can create pull-down menus. You can do some validation. We'll be covering some of this stuff. Review has to do with reviewing your work, adding comments, tracking changes, and kind of your document management type of operations. And then view just has to do with how you're physically viewing the workbook on your screen. So we've already seen zoom. You could click zoom here, and that leads us to a screen we've already seen, the zoom presets. And also, this is where the macros live. Macros are little programs, little scripts you can write to automate tasks. Now, usually you don't need to do this, but you can imagine a workbook with, let's say, 1,000,000 rows. You don't want to redo a computation or a series of computations really over and over. You can write a little script with a macro. So that's what Excel looks like. So you feeling ready to make our first engineering worksheet? Let's do it. Let's start a new workbook. So at this point, you should do everything I do. What you will be creating, you'll submit and get credit for. So let's start a new workbook. Go to File, New. And here we get a new workbook. What are we going to do? We are going to plot the bending moment in a beam. What the hell does that mean? Well, you'll learn all about this in your Strengths of Material class, and maybe even your physics class. And so the actual engineering concepts you are not responsible at all for in this class, but we're going to use it to make our first plot in Excel. So we're going to need a beam. There we go. And so this beam is going to have 6,000 pounds sitting on top of it. And for the beam to remain stationary and not be moving, that means we'll need some supports holding it up. This beam is 12 feet long. And there's our supports. So one of the things you'll learn in your classes is that forces need to balance if there's no motion. And so there we go. We've got 2 supports on the end holding up this beam that's itself is supporting 6,000 pounds. And for this not to be moving, hopefully it makes sense in your mind, if everything is symmetric, that each of these supports is going to be supporting 3,000. So there's 6,000 pounds down, 6,000 total pounds up, and you don't really need to know all of this. Here's the thing though. This 6,000 pounds, it's not going to be applied at one point. We're going to evenly distribute this 6,000 pounds. This is called a uniform load. So instead of a total of 6,000 pounds, what this is, this distributed load that we're signifying with a little w, just means that there's 500 pounds for every foot of beam. And if you do the math, hopefully that makes sense. 500 pounds per foot, there's 12 total feet, and so we get to 6,000 total pounds, but it's distributed evenly. This is a uniform load. So what's going on here, and what are we calculating? Well, if you think about what this beam is being forced to do, it's something like this. Yes, it wants to bend. That 6,000 pounds causes the beam to want to bend like this. This is an exaggerated version. And what's going on here is the 6,000 pounds is creating what's called a moment or a torque. Torque and moment mean the exact same thing. And that causes the beam to want to sag in the middle. And everywhere along this beam, there's an internal moment, the bending moment. That's what you see on the outside here. And what we want to calculate is the internal bending moment at every point along this beam. So the beam is 12 feet long. And so we want to calculate M, the bending moment, at every foot of length here. And visually, you can already kind of tell where we're going with this. If you look at the diagram and you make a guess as to where this will be the greatest, you can see very clearly the middle of the beam is where we expect the biggest bending moment, because there's going to be the most bending there. So going back to our diagram, this is what we have. We have a distributed uniform load, 500 pounds per every foot of length. There's 12 total feet of length. and we want to calculate the bending moment at any x, basically, and we're going to do that for every foot. So starting with foot 0 here on the left, and then for 1 foot, 2 foot, 3 foot, all the way to 12. Again, we expect the greatest bending moment to be at 6 feet, right in the middle there. So we need an equation, and because this is not a physics class, we're just using this as an example to make our first Excel plot and spreadsheet. I'm going to give you the equation. Here it is. Ready? Okay, so it looks a little hairy, but it's quite simple. This is the equation to find the bending moment when you have a uniform load like this. So this is an equation for m at any x you want. So x is what we will call the independent variable. Basically, you give me an x, you give XL an x, and if we do this right, it'll spit out the bending moment. X has to be in feet, and then the bending moment m will be in foot-pounds. The only other variables in here are W, the distributed load. We already know that's 500 pounds per foot, and then L, the total length of the beam, in this case 12 feet. So once again, the goal of this first exercise is to create an Excel workbook that gives us the bending moment along this 12-foot beam for distributed load, and more importantly, we're going to make our first plot. So let's dig right in. You should follow me, and we're just going to run through our first spreadsheet creation. So let's just put a little title here, bending moment example, and this is such an important title. I'm gonna make it boldface, so all I have to do, this is all this text is in cell A1, even though it doesn't look like it. Now you could expand column A, but that's going to expand all of those, so I'm gonna Control Z, undo that, and so you can see the excess is bleeding over. I'm gonna go to home and I'm gonna make that bold. Okay, so basically I have distance along the beam, and that's going to be what's called the independent variable. So that's what's changing, and based on that value, which is going to be in feet, so here in A4 I'm just going to put the units. Based on that, I'm going to have Excel calculate the bending moment. What are the units of the bending moment, which is basically a torque? Well, in this, it's going to be foot-pounds. In the metric system, that would be Newton meters. Now here's a little tidbit that I want to address right now. How could I get bending moment to not bleed over, basically? So I can expand row 3 by hovering in between row 3 and row 4, and I can drag that down. And what I want is bending moment to all fit in there. So this is the first time we're going to use the cell properties. Click on that label, which exists in cell B3, and what we're going to do is we're going to adjust the properties. So right click, and what you can see is you have a format cells option. Now click that, and you get a bunch of different formatting categories. So you can format the way a number looks, and sometimes you have cells that are, for example, dates. So you could format how the date looks, and it would have a uniform look. Or currency, you know, maybe it's dollars, maybe it's some other form of currency. But what we're going to do here is, if you go to the alignment, because what I'm interested in is fitting all of this text in one cell. So notice a few of the things you can do. You can change the orientation, which I don't want to do, but I'll show you that real quick. 79 degrees, and you can see that it rotates that. I'm going to undo that, Control Z, because I don't actually want to rotate the text. I want to fit it all in there. So what you will see is you end up using this a lot. Text control. I want to wrap the text, so I want to wrap it so that it fills top to bottom. And there we go. All right, so the idea here is that we have a 12-foot beam, and I want to have this spreadsheet, this workbook, calculate the bending moment at every foot from 0 to 12. And so the A column is just going to be distances in 1 foot intervals. So you can see what I'm doing. I'm filling these in manually from 0 to 12. Is there an easier way to do this? Yes, there is, and we're gonna cover that. And then in the B column, we're gonna have Excel computate our formula that I showed you previously. Okay, so you know, going from 0 to 12 by hand is not that hard, but what if we had 0 to 1,000,000? You know, you wouldn't want to do that by hand. So can you do that automatically? Yes. So let's select these, and I'm just going to push delete, and I'm going to show you how to do that. So starting with 0, you basically have to type in the 0. So there's no way to really get around that. And then I put in a 1, and I put in a 2. Now if you select these, what you'll see is in the bottom right hand corner you have a smart drag. So you can drag this out, and Excel will interpret the pattern that you've started by going from 0 to 1, 1 to 2. It's figured out we're going up in ones, and I don't want to go up to 21, so what I will do is I will select the bottom right smart drag box right there. It's a very small target, and I'm gonna modify that to 12. And there's 0 to 12. Let me show you one more way to do that. So again, starting with, I'm going to delete this. I'm going to try to delete this. Sometimes this happens in Excel where you have a computation and you push delete in a range and it's not going to work, so you can right click clear contents. Okay, so starting with 0, here's another way to do this. I can set up a formula, and this is kind of cool. So formula, like I said, always starts with equals. So I'm in cell A7, I type in equals, and all I want to do is add 1 plus, what do I want to add 1 to? Well, I want to add 1 to the contents of the previous cell. So what you do is, well, I could write in A6, and that would work. Other thing I could do, and notice now when I click on cell A7, my formula is now in the formula bar, so now I'm editing up here. The other thing I could do, so I redo that, is sometimes it's a lot more convenient not to actually write out the cell, but to just click on it. So now I'm going to click, instead of writing A6, I'm going to physically click on A6. Now you have to be careful here. As I'm in formula editing mode, I can't just be clicking out of this, because of course if I click somewhere else it's going to think I'm referencing that cell. I want to reference cell A6, and then that's my formula. I want to get out of formula editing, so I'm pushing enter, and there we go. Now the really useful thing about this is that we don't have to repeat this and write a new formula and replace A6 with A7 and then replace A7 with A8 and so on and so forth. The smart drag allows us to drag this down, and what you can see is that Excel has automatically incremented the row. Now if you were to smart drag to the right, what you would see is Excel has, since I was smart dragging to the right, it assumes that it's not the row that I want to increment but the column, so you can see that it's incrementing the letter of the column, which of course doesn't change because there's nothing in these other columns. And I will right click, delete that for now. And I will right click, clear that for now. Okay, so I've set up the independent variable, which is the distance along the beam. By the way, if I wanted to calculate the distance at every half foot, all I have to do is go in here to cell A7, and instead of adding 1 foot, I could add 0.5. And notice what that does. That gets me I'm going to smart drag. Now I'm going to need twice the number of rows to get to 12 for obvious reasons, because I'm making twice the number of calculations. And there we go. I'm going to go back by Control Z, because what I originally want is 0 to 12. Okay, calculation time. So we're going to make this the easiest way possible, then we're going to improve it. I have my formula up here, and I'm ready to fill out column B, and let's do it. So this is our first equation, and what you have to know is for equations, there's a certain way you have to enter them. Raising to a power, you need to use the caret. Multiply, divide are pretty straightforward, so is add and subtract, and then of course you got the order of operations. So I'm going to go back to my original formula, and so in cell B6 I am typing in my first real formula. So I put in an equals, and whenever you're working with Excel, you want to be really careful about your parentheses. So I look at this equation here and I see two things being subtracted from each other. So I like to write equations, what I describe it as doing it from the outside in. So basically I look at this and I see two things being subtracted. So I'm just putting two parentheses being one subtracted from the other. And I'm going to go ahead and fill those in from the outside. So here I have the distributed load, which is 500 times the length, which is 12, times x. Now this is the important part. What is the x? The x is the independent variable. It's going to be different on every single row. So basically the x, the distance, is the contents of cell A6. So I'm just going to click A6. And all of that is divided by 2. Now, what you could do is you could add parentheses to enclose the whole numerator, and what you can see is Excel tries to make it a little easier on you when you access either an open or closed parentheses. It colors its pair so you can keep track. So I have the whole numerator in these inside parentheses. Not necessary because of the order of operations, but maybe that's a little more clear. And in the second part here, I have minus w, which is 500, times, again, x. That's going to be the same A6. I'll put that numerator in parentheses. And that gets divided by 2. The only other thing I need to add is that second x is squared. So to do squared, I do the caret to the second power. So you can see that when you're writing Excel equations, things can get pretty hard to keep track of. So the number one thing you want to make sure you're doing is keeping track of your parentheses, and sometimes it might take you more than one shot. So if I push enter, I get 0. That's not a mistake. The bending moment mathematically should be 0, but here's the magic, the Excel magic. Smart drag, I'm gonna click on the bottom right hand corner, and you can see the cursor changes, and just drag that down. And there we go. As predicted, the bending moment is at its maximum in the middle of the beam at 6 feet. Looks like it's 9,000 foot-pounds. And we are ready to plot this, but before we do, I want to make some improvements. And this is important stuff, talking about good habits in Excel. So here's the thing. I've got plenty of numbers in this formula that don't change at all. The 500 is constant. That never changes. The 12 is constant. That never changes. This is what I'm going to do. I'm going to go to row 2, and I'm going to add some rows because I want to take those constants out of my equation, and I want them to be more easily accessible. And I'll tell you why after we do that. So I'm going to go to row 2, right-click, and insert, and do that again. I'm going to insert 3 rows. As you can see, it pushes everything down so it's nice and neat. And so what I want to do here is get my uniform load. I'm going to expand row 3 and right-click, format, get that to wrap just like I did before. And same thing with 4. My other constant is going to be the beam length. And I will also format that to wrap. And unbold these because they're not my title. Okay, so the uniform load is 500. And just for good measure, I'm going to put my units in the C column. The beam length is 12 feet. Okay, so now check out what I'm going to do. I'm going to go to my first B calculation. I'm going to go to my equation, and all I'm going to do is I'm going to replace my 500s with the contents of cell B3. And I'm going to do that once, and I will do that again. All I'm doing is selecting the 500 and clicking 500. So instead of the number 500, I'm inserting the contents of cell B3, which is exactly the same thing. And you can probably guess what I'm going to do next. Instead of the number 12, I'm just going to replace that with the contents of cell B4. And that happens only once. So when I push enter, I still get 0, and there's no reason to expect anything else because I'm using the same numbers. They're just coming from different places. And I'm going to smart drag down, and it's not going to work. And let's talk about why. So check it out. We get this value error. Now, when you get this error, that just means that the value you're trying to use is not usable. Basically, if you look at what happened, I replaced the length with the contents of B4, and I replaced the load with B3. But as I smart drag that down, you can see what happened. The smart drag worked when I didn't want it to. Basically, B3 and B4, those need to stay as B3 and B4. I don't want those to increment with a smart drag. And this comes up a lot, so we've come to an important place. I'm going to just show you something very simple, how to stop smart drag from incrementing either a row or a column or both. So it's very simple. This is how you do it. So B3 and B4, I want those to stay constant. So I don't want the 3 to change. So all you have to do is right before the 3, put a little $sign. And same thing here in front of the 4, and then I have another B3 here. Press enter. Now let me redo the smart drag. When I redo the smart drag, you can see what I get, my original answer. And so when you visually inspect the formula, you can see that B3, the 3s and the 4s don't change. Now, if you wanted to also keep the column constant, all you have to do is put a $sign in front of the letter. Of course, that doesn't matter here because I'm not smart dragging to the right. So that's very important. That's going to come up all the time in engineering. Why is that better? Well, it's better because now, let's say I wanted to change the scenario and the uniform load is now, well, let's say it's 700 pounds per foot. Instead of changing every single formula, all I have to do is click on B3 here, type in 700, and automatically all my values are updated. So it makes it much easier to change your numbers, and the worksheet is that much more versatile. Also, I could change the beam length. I could change the beam length to, let's say, 20. Now, of course, what I'd have to do here is select these. Now, notice I'm selecting both of them. Smart drag, because now the beam could go all the way to 20. And look at that. So now I have a longer beam. Pretty cool. So kicking out your constants and making them accessible on your worksheet, that's usually a good habit. I'm going to Control Z out of here, and it's time to plot these. We're going to make our first Excel plot. Okay, so got to change the beam length back to 12. How do you plot this? Very easy. And you're going to use this in all your labs at CMA. This is one of the most important things about this class. So what we're going to do is we're going to select the data we want to plot, which is going to include the labels. And so I've got all that, and if you go to the Insert tab, that's where the charts live. You can see the charts group, and look at all the different kinds of charts. You got histograms, you have line charts, you have column charts, you have something that looks like a spider web, that's a radar chart. What we want to use though is a scatter plot. Basically, you're always using a scatter plot when you have X and Y data that's paired. So like we do here, we have distance and its corresponding bending moment. So if you go to charts, scatter plots, check out, you have a few sub options. Like, do you just want the dots? Do you want the dots to be connected? Do you want the dots to be connected with straight lines? Typically, it's better to connect your dots with your data points with straight lines. That way you're not implying that there's any kind of other relationship between the points. So let's choose this. This is the scatter plot with straight lines and markers. And when you select that, pretty much builds 90% of the plot for you. We're going to have to clean it up, and so this part is very important. You could put this on its own sheet. So if I select the plot and I cut it out by Control X, you could place it on its own sheet. There it is. And you can expand it as much as you want. Let's keep ours on sheet 1 so we can see everything that's going on. I am going to make it nice and big, and so there's several things we have to do. Already we can see the shape is looking very good. Our maximum is at 6 feet, but we need to clean this up. Anytime you submit a plot for any lab at CMA or professionally, engineers are going to want to stick to a few guidelines. So you're always going to want labels, you're always going to want units, you're going to want a good title. So let's work on some of that. Let's work on the title. So we have a title in there already, but that's not really what we want. So let's replace this. This is going to be bending moment along a 12-foot beam. Rule of thumb, someone just looking at your chart should be able to read the title and from that explanation know exactly what you are presenting. Now we definitely need labels on our axes. So if you go to the design tab, you can add chart elements, and this is where all the stuff we want lives. So we're going to want axis titles for the horizontal axis. We're going to want axis titles for the vertical axis, and that'll take us to where we want to be. So to actually modify these axes, we're just going to double click them. This is distance along the beam, and that's going to be in feet. Always include your units. And this horizontal axis, you can double click that and type vertically. This is going to be the bending moment. That's going to be in pound, feet, foot, pounds, same thing. Other things we can do is if I select the chart area, I can scale that a little bit. I can change anything about the appearance of these axes. So I can make it bigger. It should be bigger, I think. I'm going to select the x-axis, and I'm just incrementing the size until this looks good. And there we go. One more little detail. The plot ends at 12, yet the scale goes to 14. How can you change these axes? Well, if I select the x-axis, if I right-click and go to Format Axis, this is where you're able to change everything about the axis itself, including the physical parameters. So you can see the minimum is set at 0, the maximum set at 14. So if I change that to 12, then I get what I'm looking for. It ends at 12. Also, notice there's a grid, and I can change the grid. Right now it's going up in units of 2. If I want those to go up in units of every 1 foot, then I just change that to 1. There's also a minor grid that is not being displayed right now. Likewise, I could right click on the y-axis, format that, and you can see that's going from 0 to 10,000, which seems reasonable. Everything about that looks good. You can add those minor grid lines if you go to the design tab. You can add, if you go to grid lines, you could add the minor grid lines to the vertical and the horizontal, and you can barely see them. Of course, you can change their properties, including how dark they are. But if I go to my x-axis properties, I could change. Right now, the minor grid lines are happening at 0.2. I could change that to 0.5, and I get a minor grid line at every half foot. Could do the same thing with the y. So right click on the y-axis, and I could get a minor grid line. It's going up in thousands, so maybe every 500. And if I do that, you can see that the grid lines change. Of course, you can also change the appearance